At resting potential, both the sodium channel and the potassium channel are closed, and the inside of the axon membrane is negative. A neurotransmitter then stimulates the sodium channel to open, and it slowly opens. Sodium enters the membrane, and it becomes slightly positive. This becomes a threshold potential. When the sodium channel opens quickly, sodium floods into the membrane, and the membrane becomes positive, reverses its charges, and causes an action potential. Then, the potassium channel opens slowly, and potassium exits the membrane. This returns the membrane to its original charge. When more potassium leaves than was initially in the membrane becomes more negative. The sodium-potassium pump then works to return the membrane to its original charge by importing potassium and taking out sodium ions. This returns the membrane to its original charge.
A nerve impulse, part 1. An impulse in the first neuron causes an action potential to travel down the axon. When the impulse reaches the synapse, it uses neurotransmitters to transfer the action potential to the dendrites of the other neuron. Pause. Part 2. A closer look at the axon and its action potential. Resting potential. Before the impulse reaches the axon, the potassium and sodium gates are closed. The membrane potential is negative inside and positive outside.
Ew, no, wait, you're not allowed to come us. Get away from us.
Threshold. An action potential
Yeah, action potential, wow!
causes the sodium gates to slowly open.
Okay, one of you can come in.
A few sodium flow inside the axon, making the membrane potential slightly more positive. Action potential. Once membrane reaches threshold, all the sodium gates open, causing rapid depolarization.
Oh man!
The membrane potential is now positive on the inside and negative on the outside. Repolarization. The sodium gates close and the potassium gates open. Allowing the potassium to diffuse down the electrochemical gradient. Losing the potassium returns the membrane potential to negative inside and positive outside. Undershoot. The potassium gates close slowly, allowing more K+ to exit the cell, making the cell membrane potential more negative than when it was at resting potential. Pause. Sodium-potassium pump. A sodium-potassium pump takes 3 sodiums out of the cell and puts 2 potassiums into the cell. Through means of active transport. Eventually, the original cell concentration of potassium and sodium will be restored. Pause. Okay.
Last skit. This is the third of 3 skits in period 1. 10.
Hero! Transmitter! Open the gates! Open the sodium channel, please. Where are the channels? Sodium!
Sodium?
What? Sodium, go! I feel so positive! Oh my gosh!
I feel so positive
I'm the
now.
most positive I've ever felt! I'm gonna transfer my happiness!
Ew, impulse! We're so happy we can get rid of our potassium flip-flop.
Let's do that,
Yeah, jump in.
guys.
Open the gate.
Hi, Bob. We don't need you anymore.
Oh my gosh!
Something's wrong.
I feel so negative.
What have we done?
Oh my gosh! Can we exchange some of our positives for your negatives so we can feel more balanced, please? Alright. Here you go. Here's some potassium.
I'll be back.
Thank you.
It's nice
I
doing
feel
business
so more
with you.
balanced now, guys.
Yeah, let's go back to sleep.
Let's go back to resting.